Welcome back. So this lecture, I'm going to go through resonance structures. What will happen if we can have more than a single bond? Okay. So example that I came with is NCO minus 1. Okay. So in this case, we have nitrogen, it's a group 5. Carbon, group 4. Oxygen is a group 6. That means it has 6 valence electrons, and the charge is equal to -1. So in order to draw a Lewis structure of this species, we need to know the total valence electrons. Okay, so we're going to start with total number of valence electrons. Okay, and we're going to say we see 1 nitrogen plus 1 carbon plus 1 oxygen minus the charge. So I go 1 multiply 5 electrons for nitrogen plus 4 for carbon plus 1 multiply 6 for oxygen minus the charge. And the charge is -1. So minus of -1. Okay. And that's going to give us 10 plus 6. It will be 16 electrons. Okay. Electronegativity, it says oxygen has the highest electronegativity, then nitrogen, then carbon will be the least. Remember, electronegativity to the right side of the periodic table increases, down in any group decreases. And because we are dealing with the same period here, all these elements belong to the second period. Okay, the one on the right side of the table, in the periodic table, it will have the highest electronegativity. So oxygen has the highest. And the one with the lowest will be the central atom. So carbon will be the central atom. And remember, we do have 16 electrons. So we have 16 electrons totally, and carbon is the central atom. I go, carbon is the central atom, forgive me. And then you can put nitrogen, oxygen anywhere. Okay, and I have 16 electrons, so I'm going to use 2 electrons per each bond. Okay, so I made 2 bonds, and I used 4 electrons for those 2 bonds. So minus 2 bonds, and per each bond, 2 electrons. So now we are plus 12. What should we do with those plus 12? You draw a circle around each element. And remember that electronegativity is telling you oxygen is the most electronegative element. Okay. So now, after those 12, use 6 of them to make oxygen happy and make it active. So here you go. I give it 6 electrons. So now I have 7 electrons inside the circle. We made 1 sigma bond, okay, plus 1, it will be active. So oxygen is happy. Okay. Next, we're going to focus on nitrogen. We will give nitrogen also 6 more electrons. So it will be 7 plus 1, 8. We use all the electrons, so we are left with nothing. Okay, how about carbon? Carbon, I see 2 electrons inside the circle and made 2 bonds. So you say plus 2 bonds. Total, we have 4 electrons. Carbon is not active. You need to make carbon active. Remember, in organic chemistry, we cannot have carbon with less than 8 electrons. Otherwise, it will be unstable. Okay, what's the solution for it? You're going to write here. You're going to write reference, and you say, this is my reference. I'm going to take this structure, and I will copy paste it another page. Okay, so let's copy paste this one. And I will do it 3 times because I have 3 options. Okay. Now, what's the first option? First option, carbon is missing 4 electrons. we can take 4 electrons from nitrogen, or 4 electrons from oxygen, or 2 electrons from nitrogen and 2 from oxygen to make carbon happy. Okay, so first step, first option, first one, let's take 4 electrons from nitrogen and share them with carbon. So please look carefully. Look what I'm going to do. First, I'm going to erase one lone pair. Okay, this lone pair is gone. Okay, that lone pair is gone. Okay, next, now that you erase the lone pair, you will draw it as a new bond and you show it here. Okay, this bond is made of 2 electrons. Okay, another lone pair, I can erase that lone pair. Okay, show it by another bond. Okay. Now I got a triple bond. The second and third bond, we call them pi bonds. Okay, so the second and third bond, okay, call them pi bonds. Okay, those are pi bonds. You can repeat this one with oxygen. Okay, so second structure, it will be 3 lone pairs from oxygen. Again, it doesn't matter which lone pair, just erase 2 lone, forgive me, yeah, share 2 lone pairs from oxygen with carbon. It doesn't matter which one. So let's erase this, that's gone. And then next step, I'm going to draw it as a double bond. Okay, another lone pair, I can go after this one. Okay, now we'll show it as, okay, triple bond. Okay, that's another option. Or we can share one lone pair from each element. So let's go after this lone pair from nitrogen. That's gone. Now we're going to show it as a double bond. Double bond between carbon and nitrogen. Another lone pair from oxygen. Okay, those are pi bonds. Okay. Okay, so now let's check the octet rules. Okay, I'm gonna right here. I see 5 electrons inside the circle. We made 3 bonds. That's 8. Carbon. I see 4 electrons inside the circle. We made 4 bonds with carbon. That's 8. Oxygen. There are 7 electrons inside the circle. So you go 7 electrons inside the circle. We made only 1 bond with oxygen. That's going to make it octet. And you repeat this one for rest of them. Okay, like in other elements inside the second and third Lewis structure. Okay, so I go here. I have 7 plus 1, 8, 4 plus 4, 8, and 5 plus 3, 8. Okay, for nitrogen, I see 6 electrons, so I go 6 electrons and made 2 bonds. It will be 8. Carbon, 4 plus 4, 8. And this oxygen, it will be 6 plus 2, 8. Okay, so all of them are octet. Okay, next, we're going to check the formal charges. Okay, formal charges, I'm going to write them with red color. Okay, so first element is nitrogen. Nitrogen is a group 5. On the periodic table, nitrogen is a group 5. Minus. How many electrons inside the circle do we see? We see 5 of them. So you say minus 5. And that's going to give you 0. Repeat this one for carbon. Carbon is a group 4. I see 4 electrons inside the circle. Okay, so this one, it will be 4 minus 4 electrons inside the circle, it will be 0. How about oxygen? Oxygen is a group 6. But I see 7 electrons inside the circle. I see 7 electrons inside the circle. So I go -7, and that's going to give me -1. Now highlight the charges. -1, 0, 0. When you add all the formal charges, they are supposed to be equal charge of the anion or the cation. Example that we're talking about it is NCO -1. This is an anion, a species with a negative charge, okay? And when you add the formal charges, all the formal charges, they need to be equal to the charge of the anion. Okay, and here we go. We got it -1. If you repeat this one for the rest of the, like the elements, okay, you will get nitrogen here. It will be 5 minus 7. It will be -2. 4 minus 4, it will be 0. And this one for oxygen, oxygen is a group 6 minus 5 electrons around it. It will be +1. Okay, let me highlight them. Okay, so +1, 0, -2. If you add them, the answer is going to be -1. It still is correct. Okay, next. I go nitrogen is a group 5. I see 6 electrons around it. It will be -1. Carbon, 4 minus 4, 0. Oxygen, 6 minus 6 electrons around it, 0. Okay, again, let's highlight the charges. 0, 0, -1. Okay, now time to talk about what's the best and what's the worst Lewis structure. Okay, the best and worst Lewis structures. Okay, when you find the formal charges and you add them, the total, their total has to be equal to charge of the anion. And we proved it in all Lewis structures. We got them equal to -1. So let me go back for a second. Okay, if you add all the formal charges, the blue, the purple, like the red, or let's say yellow, when you add them, answer is -1. Okay, so that one, we got it correct. Next. Now, what's the best Lewis structure? The best Lewis structure is the one with the lowest formal charges. Okay, structure that has all of them are 0, 0. That's going to be the best. Okay, if you have to have a charge, the one that has minimum number of charges, like maybe just 1 minus 1, and the rest 0, 0. That's going to be the best. Okay, so now let's check. I have two structures. Structure number 1, it has only one charge, and it's -1. And structure number 3, also it has only one charge, and that's -1. Okay, so I got 1 and 3 with only one charge. Okay, how about number 2? Number 2, it has +1 and -2. That's going to be the worst structure. Okay, so I'm going to say the highest structure, okay, the highest structure, or the high structure with the highest energy will be number 2. That one, it will be the most unstable. Okay, the most unstable structure. Okay, that's going to be the worst one. Okay, next. Okay. Between 1 and 3, which one is going to be the best Lewis structure? Let's read this. It says, if you're supposed to have a negative charge, put it on the most electronegative element. Okay, put it on the most electronegative element. And remember this, that electronegativity of oxygen higher than electronegativity of nitrogen, nitrogen higher than electronegativity of carbon. Okay, now what's the difference between structure number 1 and number 3? It's going to be just the negative charge. Negative charge here is on oxygen. Well, this one, the negative charge is on nitrogen. So what's the best Lewis structure? The best Lewis structure, it will be number 1, because it has negative charge on oxygen. Number 3, it has a negative charge on nitrogen, supposed to be oxygen. Okay, so this negative charge should be here, not on nitrogen. So I'm going to say the third structure will be after number 2, and the best Lewis structure will be number 1. So this one, it will be the best. The best structure. Okay, so the best structure is structure that has negative charge on the most electronegative element. Okay, so what did I get? I got 3 structures. Okay, and the difference between them, difference between them technically is the position of the double or triple bond. Okay, so let's start with this. Let's start with this. We have nitrogen attached to carbon, carbon attached to oxygen. Okay, this one can be transferred to structure that has 2 lone pair nitrogen, double bond between carbon and nitrogen, and double bond between carbon and oxygen. And oxygen has 2 lone pairs. Okay, this it can be transferred. Okay, this one it can be transferred to structure that has a triple bond between oxygen and carbon. Okay, so triple bond. Oxygen has only 1 lone pair, and a single bond between carbon and nitrogen. Nitrogen has 3 lone pairs. Okay, 3 lone pairs. Okay. So if I highlight the triple bond, so triple bond used to be between carbon and nitrogen. Now we turn it to a double bond. How we moved? Okay, we moved this one. I'm going to highlight top one. Top one, we moved it here. Okay, we moved it there. Okay, if you can move structures. So this one was, this one was number 1. That's number 3. This one was, I believe, let me double check it. Okay, that's number 2, and this one will be number, this is number 2. That's number 3. If you can transfer one loose structure to another one by moving the electrons, we say you are dealing with resonance structures. Resonance structure. What's the meaning of resonance? Resonance means the electron can move. Okay, electron can move from from 2 elements, like as a bond between 2 elements, to different pairs. Okay, if you move the electron from nitrogen carbon to carbon oxygen, we say the electron resonance to different position. Okay, so the resonance here means, like you change position of the electron. Okay, and we use this sign between them. Okay, this sign in vector that has double head, that means you are dealing with resonance structure. So every time you put like the vector or double, and like vector with double head, and them, or arrow with double head, that means you're dealing with resonance structures. Okay, I hope this lecture was useful. Thank you very much.